Good evening, Pavel Chirich and friends. Sorry if my throat is a bit and my voice is not the loudest, but I have a very sore throat. Today we will be dealing with function transformations. And in these kinds of questions relating to function transformation, we are told how a function behaves when its input has been transformed. Our goal is to find the original function, meaning the rule for the function of fx itself. To do that, we must follow these steps. First, look at example 1. We have f of 4x minus 1 is equivalent to 5x plus 2. What is f? What is the function? The first step we need to do is we have to involve another variable. So I'm going to use the example of t. We're going to say t is equal to what is in here. So t is equal to 4x minus 1. And what we need to do is we need to simplify this so we get an equation that shows what is a singular x equivalent to. So from here, let's put the 1 to the other side. T plus 1 is equal to 4x. And then from here I can do this a bit. From here, if we want to get x by itself, we have to divide it by 4, same as this. So we now have x, as we've divided it by 4 here, is equivalent to t plus 1 over 4. Cool. Okay. I always like to put this in a little box. Now, using this information, we're not going to put it into here, but into this second part of this equation. Okay, so now we know that what we're going to put is 5 times, you can do a little dot or a little times, simple as I like, 5 times t plus 1 over 4 plus 2. Remember to put here, I forgot to do it first, the function of t. We've got to do that now, as we're doing that instead of x. Okay. From there on, we are now going to simplify this. 5 times t plus 1 over 4, it is equal to, 5 times, sorry, 5t over 4 plus 5 over 4 plus 2. This can be separated into 2 fractions. It is the same. From there, this is equivalent to what we're going to do is we're going to make this 2 into a fraction. We know if we were to put it over 4, the 2 would be equivalent to 8 over 4. So now we have 8 over 4 plus 5 over 4, which is 13 over 4. So now we have 5t over 4 plus 13 over 4. Now we're going to put this back into fx. How would I say, maybe notation? Fx. Where we're going to replace t with x. Fx is equal to 5 over 4x. You could also do 5x over 4. It's the same. Oppa. Plus 13 over 4. Oppa. Moving on to the next example. We have f half of x plus 1 is equal to 3x minus 4. Remember the first step. Make a separate variable. Mine is, let's get the light. Mine is t. T is equal to what's in this bracket? Half of x plus 1. From there, remember, we need a singular x. Well, to see what the singular x is equivalent to. Excuse me. So now we're going to put this one to the other side. When you have one, what you do to one side, you do to the other. So if we have a plus 1 and we want to bring it to the other side, we have to minus 1. So t minus 1 is equal to half of x. Now we need singular x, so we're going to times this everything here by 2. So now we have half of x times 2 is x, so x is equal to 2t minus 2. As I say, I like to do it so we don't get confused. We put this all together in a square. Now we're inputting this into this. Okay? F of t is equivalent to we can just see this quickly. Or actually, for the purpose of learning, I'll just put it like this. For 3 times x, x here is 2t minus 2. So 3 2t minus 2 take 4. This is equal to 6t take 6. Take 6 take 4. This is equal to this is equal to 60 take 10. Okay, now that we found out this simplified, we're going to write f, the function of x, is equal to, remember to replace t with x, 6x minus t. Now on to the last example. We have f of 2x minus 3 over 2 is equal to x plus 5. As I've said before, first thing, I was meant to write f is equal to what? T, the variable, is equal to what's in this bracket. So we have 2x minus 3 over 2. From there, because we can move, okay, I'll just show it. We want to move this to this side, yes? Oppa. We want to move this to this side. So t, so if we have minus 3, 2, we're going to make it plus on the other side. Plus 3 over 2 is equal to 2x. Now, we kind of have a little problem. We can't, in order to get a singular x, we have to divide. We have to divide this 2x by 2. But we would also have to do this to the other side. and we have 3 over 2 here. You can't divide 3 over 2 by 2. Well, you can, but it'll just get messy. So I recommend just making it, how would I say it? Writing it just using a different denominator. So t plus 6 over 4 instead of 3 over 2. But that's not the neatest. Is equal to 2x. Now from here we can divide by 2. We've got half 1 over 2t plus 3 over 4 is equal to x. I'll write it down like this. X is equal to 1/2 of t plus 3 over 4. It's hard writing, so it's a messy box. Now finally, input this value into this. X is equal to 1/2 of t plus 3 over 4. So remember, f t is equal to 1/2 of t plus 3 over 4 plus 5. Now we're going to make this 5, the value of 5, to have a shared denominator as 4. So what would be the equivalent value of 5 if we need the denominator of 4? It would be 4 times 5 over 4. So that is 20 over 4. So we have, this is equal to 1/2 of t plus 3 over 4 plus 20 over 4. This is equal to 1/2 of t plus 23 over 4. Fx is equal to 1/2 of x plus 23 over 4. There you go, the answer for that one, the answer for this one, the answer for that one. Buonanotte.